Hey everyone, and welcome back to my science studio. In the last lesson, we learned how to use molar mass to go from grams to moles and moles to grams, and we talked about what I like to call the mole bridge. So, how the mole can help us travel between grams and particles, whether that's atoms, ions, formula units, molecules, you name it. But today, we're going to be taking the next step. I'm going to teach you what a mole ratio is and how we can use it to convert from one substance to another and eventually from grams to grams. So let's get started. Okay, what is a mole ratio? You see, whenever you're given a chemical equation, the first thing I tell my students to check is whether or not it's balanced. Why? Because the coefficients in a balanced equation tell us the exact ratio that substances react. And that ratio is called the mole ratio. And it acts as a conversion factor between different substances in the same reaction. So, for example, let's say you have nitrogen reacting with hydrogen to produce ammonia or NH3. Looking at this, I know this is balanced because I have an equal number of nitrogen and hydrogen on both the left and right sides. So, what the coefficients are essentially telling us is that for every 1 mole of nitrogen reacting with 3 moles of hydrogen, we're going to produce 2 moles of ammonia. Those numbers, the 1 to 3 to 2, that's the mole ratio. So whenever you need to go from one substance to another, you must use the balanced chemical equation. Let's go ahead and try this problem step by step together. Here we have hydrogen reacting with oxygen to form water vapor. And the question's asking for how many moles of H2O are produced if 5.0 moles of O2 react completely. The first thing I want you to identify is your mole ratio, right? So we know from this balanced chemical equation that for every 2 moles of H2 that react with 1 mole of O2, we're going to produce 2 moles of H2O. Now let's go ahead and set up our problem, just like how I taught you in the last lesson, with what you're being asked equals what you're being given. So start by writing what you want. Question mark, so how many moles of H2O are in 5.0 moles of O2? So we're going here from one substance to another. So we got to use our mole ratio. So from the balanced equation, we know that for every 1 mole of O2, we're going to produce 2 moles of H2O. So when we open up a parentheses and draw a fraction, we can place the 1 mole of O2 at the bottom of our fraction in the denominator. Why? To cancel out our moles of O2. And then at the top, we can place the 2 moles of H2O. Multiplying across, 5 times 2, that's 10. But because the question is originally giving you 2 sig figs, you have to report the answer to 2 sig figs as well. So the 10, you have to put a decimal after that 0 to denote 2 significant figures. And that's that. Okay, I encourage you to go ahead and pause the video and try this next problem on your own. And when you're ready, go ahead and press play and we'll do it together. So in this question, we have a decomposition reaction of potassium chlorate, and the question is asking how many moles of O2 are produced from 12 moles of KClO3. So the first thing you want to do is set up our problem. How many moles of O2 are in what you're being given, 12 moles of KClO3? Now, because we're being asked to go from moles of KClO3 to moles of O2, we have to do a mole-to-mole ratio using the coefficients from our balanced chemical equation. So opening up a parentheses and drawing a fraction, we can say that for every 2 moles of KClO3 that decompose, we're going to produce 3 moles of O2. Again, we put the moles of KClO3 at the bottom so we can cancel out with the moles of KClO3 that are given to us in the question stem. So that what's left uncanceled is the moles of O2. So now plugging it into our calculator, we say that, okay, 12 times 3 divided by 2 gives us 18 moles of O2. Okay, so now I'm going to teach you how you can go from grams of one substance to grams of another substance using molar mass and mole to mole ratios. So hopefully things start making a little bit more sense. If you have grams of A, right? And A can be any substance, and you want grams of B, another substance. You cannot do it in one step, and you also can't do it in two. You must go through three moves, kind of like a game of chess. And the idea here is if you start with grams of A and you want to get to grams of B, you need to first go through the mole. Remember in my last lesson, I talked about the mole bridge? And it's essentially this idea that the mole can help you cross from one substance to another. So we need to go from grams of A to moles of A first by using the molar mass of A. Once we have moles of A, we can get to moles of B by using a mole to mole ratio. And once we have moles of B, we can get to grams of B by using the molar mass of B. Let's go ahead and try this problem together step by step, and things will start looking a little bit more clear. The question says, if 25.0 grams of calcium carbonate decomposes according to the following equation, calculate the mass of carbon dioxide produced. Okay, I'm looking at this equation and it looks balanced to me, so we can proceed with our setup. First, start with what you're being asked. How many grams of CO2 are in what you're being given? 25.0 grams of CaCO3. So we have calcium carbonate and we want to get to carbon dioxide, grams to grams. You can't do that in one step or two, so it's going to be a three-step process. So the first thing you want to do is convert from grams to moles by using the molar mass of calcium carbonate. Now, if you don't know how to find the molar mass, I highly recommend you check back on some of my last lessons on this to help you refresh your memory. When you plug it into your calculator, you should get about 100.086 grams of calcium carbonate per 1 mole of calcium carbonate. Now we place the grams at the bottom so that we can cancel with the grams of calcium carbonate that are given to us. So we're left with 1 mole of calcium carbonate at the top, right? So we're at moles. Now we need to cross from moles of calcium carbonate to moles of carbon dioxide using a mole to mole ratio. And this equation is nice because if you notice, the ratio is 1 to 1 to 1. So I know that for every 1 mole of calcium carbonate, we're going to place it at the bottom to cancel out with our moles of calcium carbonate. We then place the 1 mole of CO2 at the top of our fraction here. Now that we have moles of CO2, we can convert to grams of CO2 by using the molar mass of CO2. So, plugging in the values from your periodic table to find the molar mass of CO2, you end up getting 44.009 grams of CO2 per 1 mole of CO2. We place the 1 mole of carbon dioxide at the bottom of our fraction so that we can cancel out the moles of CO2 from the last step we did. Okay, now we're going to plug all this into our calculator. So this is like saying 25 divided by 100.086 times 1, right? 1 over 1 is just 1, times 44.009 grams of CO2. And we end up getting a number about 10.9927962, right? Something like that. Now, the question is giving us three significant figures, right? 25.0. So our answers should be reported to three significant figures. So looking at this 9, we look next door to it. Because it's above a 5, we're going to round up. So the answer is 11.0 grams of CO2. Now, I encourage you to go ahead and pause the video and try this next problem on your own. And when you're ready, press play and we'll walk through it together. So the question states, nitrogen reacts with hydrogen to form ammonia in the following reaction. How many grams of ammonia are produced if 12 grams of hydrogen reacts completely? The first thing I notice is that it's not balanced. So let's go ahead and balance it first. We have N2 reacts with H2 to produce NH3. We only have two nitrogens on the left and only one on the right. So if we place a 2 as a coefficient in front of the nitrogen on the right, now we have two nitrogens. But we also now have 2 times the amount of hydrogen on the right. So 2 times 3 is 6. So to balance that with the left side, we got to place a 3 as a coefficient in front of the H2, so that 3 times 2 is 6. Now we're good. So our ratio is, for every 1 mole of nitrogen that reacts with 3 moles of hydrogen, we produce 2 moles of ammonia. Fantastic. Now let's set up our problem. First, start with what we're being asked. How many grams of ammonia are in 12.0 grams of hydrogen? And exactly like the last problem we just did, we need to first convert from grams of hydrogen to moles of hydrogen using the molar mass of hydrogen. And remember, hydrogen written by itself is usually a diatomic, right? So you have to multiply the atomic mass of hydrogen on the periodic table by 2, and you end up getting 2.016 grams of hydrogen per 1 mole of hydrogen. And remember, we place the grams at the bottom so that we can go ahead and cancel the grams. Now we have moles of hydrogen. So how can we make our way across to moles of ammonia? Well, we can use our mole to mole ratio. So we know that for every 3 moles of hydrogen that react, we place it at the bottom. Why? So that we can cancel the moles of hydrogen. We're going to produce 2 moles of ammonia. That's what we're going to place at the top here. Now that we have moles of ammonia, we can go ahead and convert to grams of ammonia by using the molar mass of ammonia. So when you find the molar mass of ammonia, you end up getting a value that's about 17.031 grams of ammonia. We place it at the top of our fraction per every 1 mole of ammonia. Again, why? Because you want to cancel the moles of ammonia with the moles of ammonia from the last step that we did. Now, go ahead and plug all this into your calculator. So we have 12 divided by 2.016 times 2 over 3 times 17.031. And you end up getting about 67.583, and it repeats, right? Now, because the question is giving you 12.0 grams to start, we have 3 significant figures. So our answer has to also be reported to 3 significant figures. So the third sig figure is the 5. When you look next door to it, it's above the 8 is above a 5, so you round up. So our final answer is 67.6 grams of ammonia. And that's mole ratios and gram to gram stoichiometry, you guys. If this lesson helped you at all, please don't forget to like and subscribe to my channel. And don't forget to download my free worksheet below so you can follow along with my lesson anytime. Thank you guys so much for watching. I will see you next time in my science studio. But until then, happy studying!